continuation of the softening. Okay, limitation of reverse osmosis, high capacity and operating cost. Managing the wastewater brine solution is a potential problem. Okay, high level pre-treatment is required in some of cases. Membrane are so prone to fouling. Produce the most wastewater between 25 to 50% of the feed problem with the reverse osmosis. Okay. Now, overview of RO and nanofiltration. Most RO and nanofiltration system have the same type of inlet collection tank, feed pump skid and tank. Okay, a filtration system, membrane and modular rack, receiving tank, backwash of the receiving tank. Okay, chemical cleaning system, compressed air for fouling member when they are cleaned. Okay, automation instrument. Okay, membrane element, hollow fabric model. This typical hollow fiber model may be consist of several hundred over 100 to 1000 fibers. Although dimension vary by manufacturer, approximate length hollow fiber or construction are outside diameter 0.5 to 2 mm, inside diameter 0.3 to 1 mm, fiber wall thickness 0.1 to 0.6 mm, fiber length 1.1 to 2 meter. Plate and frame, the membrane are placed on the top of the plate-like structure that collects the solid inside of the supporting plate. These have low packing density and can be less efficient than other filtration methods. Spiral wound membranes are among the commonly used. They are compressed of flat sheets of the membrane between mesh-like spacer that round around the central tube. Tubular, several tube-like membranes are placed within pipe shells. As they are stream passed through the tube, it transfers the premitte of the pipe shell side. Okay. Conventional pre-treatment technique for RO and nanofiltration, solid reduction, scale control, microbiology, fouling. Okay. Disinfection. Disinfection of the water is process of removing pathogenic bacteria from the water by chemical. Chemical used for killing these diseases, producing the bacteria known as disinfectant. Okay. Sterilization is the process of killing all the bacteria by boiling. A requirement of good disinfection, very important. They should destroy all the harmful bacteria and make the safe for use. They should not take more time to killing bacteria. They should be economically easily available. They should not require high skill for their application. After treatment of the water, they should not become toxic and objectionable to the user. The concentration should be determined by the simple and quickly. Okay, methods of disinfection. Physical method, boiling. Boil the water 15 to 20 minutes and kill the diseases causing bacteria. This process applicable for individual home. Very important. Ultraviolet ray, water allowed to pass through the 10 cm thickness by ultraviolet ray. This process is very costly and not used by, so it is not suitable for institution. Water works, okay, suitable for institution. Ultrasonic ray, suitable for institution, this also, okay. Chemical method, chlorination, first one, chlorination disinfection. Use the chlorine gas or chlorine compound. Next, bromine and iodine. It is expensive and leaves the taste and odor. Potassium permanganate. This method used for disinfection of dug well water, pond, okay, pond water or private source water. Ozone is a very expensive process. Leaves no taste, odor and residual. Excessive lime treatment need long detention time for time interval and large time sludges to be treated. Okay. Chlorination is the treatment of water with the chlorine for disinfection of water. Chlorination not only disinfection but also remove the color, odor, unpleasant taste and prevent the growth of weeds in water. Form of chlorination: bleaching powder, chloramines, chlorine dioxide, free chlorine gas, liquid chlorine. These are the form of chlorine: bleaching powder, chloramines, chlorine dioxide, free chlorine gas and liquid chlorine. Okay. Advantage of chlorine: chlorine is manufactured easily by electrolyte common salt NaCl. It is powerful oxidant and can be penetrate cell wall of the organism, and it contains dosage can be controlled precisely. It can be easily detected by simple orthoiodine test. Does not form a harmful constant reaction with the organic of the inorganic in water. Leaves liquid residue in water to neutralize the recontamination later. These are the advantage. Precaution in using chlorine. Okay, chlorine gas or liquid highly corrosive and lethal to inhale. Hence, it is stored carefully sealed container at a distance. Okay, highly corrosive. Okay, so it sealed carefully container in a distance. The water contains phenolic compounds. There is a reaction with the chlorine can result cancer-causing substance. Very dangerous. It may cause us cancer. Okay. Residue chlorine and chlorine demand. When chlorine applied in water, some of the consumed in killing pathogenic, some react organic, inorganic substance. Balance is detected as a residue chlorine. The difference between the quantity applied per liter and residue is for chlorine demand. Polluted water exerts more chlorine demand. If the water treatment, sedimentation and aeration, chlorine demand may be reduced. Normally, residual chlorine is 0.2 mg per liter is required. Okay, very important, residual chlorine. Now we go for the dosage of chlorine. Plain chlorine, okay, superchlorination, breakpoint chlorination, dechlorination. A, where we see this is the plain chlorination. B is we are writing superchlorination, okay, breakpoint chlorination and dechlorination. D is the dechlorination, okay. Breakpoint chlorination, and this is the chlorination dosage and residual chlorine. This is very important. Okay, plain chlorination, B superchlorination, breakpoint chlorination, and okay. Next point of chlorination: pre-chlorination, post-chlorination, and rechlorination. Okay, pre-chlorination. This is very important point of chlorination: pre, post, and rechlorination. Defluoridation is a process of removal axis of fluoride present in the water. Okay, dechlorination. Fluoridation is adding the fluoride. Defluoridation is process of removal of axis fluoride present in the water. The axis of fluoride in water causes, what are the causes of axis of fluoride? Dental problem, hypertension, hepatic ulcer, skin infection, okay, detective vision, coronal thrombosis, and permissible level of fluoride of the water is 1 mg per liter. Okay. Method of removal, okay. Activated carbon prepared from the various material can be used. Activated carbon prepared from various materials from the lime soda process of water softening removes the fluoride also along with the magnesium. Okay. Lime soda process of water softening removes the fluoride along with the magnesium. The material like calcium phosphate, bone charcoal, synthetic tricalcium phosphate may be removal axis of fluoride. Water may be allowed to pass through the filter bed contain fluoride retaining material. Okay. Thank you. This is about the softening A and B part. Okay.